Yeah, hi, I'm Zhang from University of Michigan. I'm very excited to finally have the chance to present anything in person, which didn't happen in the past 2 years. This is a joint work with Fang-Yi, Grant Schoenebeck, and David Kempe. In this talk, I will present a system-level analysis of conference peer review. We are interacting with the conference, especially for those large computer science conferences. I bet everyone here has experienced at least one of these cases. So as authors, we often feel that our papers are not well evaluated. As attendees of a conference, we find there are less interesting works, or there are just too many works to locate the really interesting ones. And of course, as reviewers, we complain about the overwhelming reviewing workload. So what's wrong with here? Or maybe you can improve it. And that's indeed the case. People from computer science community have noticed the problem and they decide to meet up and do some brainstorming. This is what they got. A Google Doc full of 23 pages of comments of ideas on how to improve the peer review system. I'm not expecting you to read every details of this, but here's an interesting idea. Why not we just accept more or even all the papers? The intuition is that every paper rejected at the conference will eventually keep resubmitting and eventually got accepted. So why don't we just lower the acceptance threshold and accept them all at the very beginning? In this way, we don't have to read them over and over, and we save the reviewing workload, right? This is a very interesting idea and sounds plausible. However, our model, as we will see, predicts something different. This may not be an issue that as simple as we thought it's going to be. So back to the question, what should we do to improve our peer review system? Here are some ideas, and some of these have actually been implemented these days. How about we lower the acceptance threshold? How about we solicit more reviews per paper? Know that it is no longer rare for a machine learning paper to be solicited with 5 or even more reviews these days, right? How about we improve the review quality? Here's an interesting one. Shall we require previous review to follow the resummations? In this paper, our main contribution is that we provide a general model and several instantiations to analyze the problem. Furthermore, we will provide some insights into how this idea would impact the review system. So to evaluate these ideas, we first have to understand what is our goal. From the conference point of view, the goal is to maximize the quality, which means the conference wants to accept more good papers and reject more bad papers. The problem is that we don't actually know what is the true quality of the papers. What we can do is to draw some noisy reviews, and based on the reviews, we make the decision, right? So the problem is that the conference, aiming to maximize the quality, will just solicit an infinite number of reviews per paper. And after fully assess the true quality of the paper, make the decision. This definitely will maximize the conference quality. But this is not realistic. The problem is that there's a second dimension of the problem that we haven't looked at, which is the review burden. Of course, we cannot optimize the review burden and conference quality at the same time. There's always a trade-off. So one of our key links in this paper is to understand how does the conference acceptance policy would trade off the conference quality and the review burden. So the rest of this talk, we will first provide a very simple model to gain some insights. And we will talk about the other best response, and then we talk about this trade-off between the conference quality and the review burden. Finally, we will conclude. The model is very straightforward. Consider n authors, each with a paper to submit. There's only one prestigious conference. And the paper's quality you can consider as scalars, like real numbers. They are IID joined from some prior P. Now consider there's a paper with quality Q. The author of that paper will face a binary decision, whether to submit to the prestigious conference or just submit to the sure bet. For a sure bet, you can consider this as a second-tier conference, which always accept and return a value of 1. The prestigious conference, on the other hand, will accept with some probability determined by the acceptance policy phi and the paper quality Q. The value of the prestigious conference is V, which is always higher than 1. After the paper is submitted, the conference will respond with a binary decision, whether to accept or reject, right? So if the other paper got accepted, the other will gain some utility. And if the other paper is accepted by the sure bet, the other will gain some smaller utility. However, if the paper is rejected by the prestigious conference, the other will gain nothing in this round. and face the same problem in the second round, third round, until the paper got accepted by either by the prestigious conference or by the sure bet. The other utility is a proportion to the conference value, which is V for the prestigious conference and 1 for the sure bet. And this utility is time discounted, which means if the paper got rejected for t times, the other utility will be V times eta in the power of t. It's exponentially discounted. Very simple. Next, we will also consider this simplified setting. We call this the idealized setting in this talk. Well, in our paper, we definitely have more discussions on more generalized and complicated models. Let's consider paper quality are just all the real numbers. So it can be negative, can be positive. And we assume the reviewer noise is an additive zero main Gaussian noise. That means the signal the reviewer sees, which is S, will be equal to the true quality of the paper plus an error term, which follows the Gaussian distribution. We assume the policy, the acceptance policy, is a memoryless and a threshold one, which means the conference will draw one review per round, which is S, and set the threshold on the signal space. That means the conference will accept the paper if and only if the review signal S is higher than the threshold tau. So consider this figure with the Gaussian noise, which is the signal distribution. Then the probability of acceptance will be exactly the gray area. We further assume authors are noiseless, which means they can actually say the true quality of their papers. This greatly simplifies the problem as the author's belief will not be changed with the reviews. So no matter how many rounds of the paper is rejected, the author will face the same problem every round. So this leads to a very clean results, that is, in this idealized setting, the author's best response is actually a threshold one. So the author will submit and keep resubmitting the paper until the paper got accepted if they think the quality Q is higher than the threshold theta. On the other hand, if the Q is smaller than theta, the author just immediately take the sure bet.
Sorry, can I just ask a clarification? Where does the prior P play into your model?
Right, the prior P is the paper's quality prior. Right.
But if the author knows the exact quality and the reviewer also sends a signal that's just the true quality plus some noise, right, why does the prior matter?
Right, so the prior matters to the conference because the conference will set a, the conference will set a threshold. Yeah.
The threshold is in
Yeah, yes, exactly. Yeah. Right, so there's some intuition about this proposition. That is, we figured out is actually all that matters about the conference part is this attractiveness. We define this as a rho which is a ratio determined by the conference value V and the other discount eta. So this rho is always higher than 1, and if the higher V is or the higher eta is, the ratio will increase. And why we have this proposition, the intuition is that the author will submit if and only if he thinks the probability of acceptance is larger than 1 over rho. And furthermore, the probability of acceptance is monotone increasing in paper's quality Q, which results in the threshold best response. So how to interpret this proposition? Consider the conference set a threshold tau and is willing to accept only the papers about tau, which is this gray area. But wait, that's not going to happen. The paper that eventually got accepted will be the paper that are above the author's best response threshold, which is the blue area. So de facto, every paper in this blue area are submitted and keep resubmitted, eventually got accepted. We thus call the theta the de facto threshold, which kind of captures the author's self-selection. Theta is related to tau, but not equal to tau. There's a gap between tau and theta. We call this the resummation gap, which is caused by the review noise. Right? You can imagine that the author will try to take advantage of this noise, so there's a gap. Right? So if you ask, what will enlarge the resummation gap? You can consider that if we set a threshold tau, what will attract more authors to submit? There are 3 aspects. A higher value conference, authors are more patient, and reviewers are noisier. All of this will enlarge the resummation gap. Let's keep that in mind as we will revisit it pretty soon. So this leads to a very fascinating phenomenon. We call this the Resumation Paradox. Every submitted paper is eventually accepted. But most of these papers are rejected a lot of time before acceptance. Let's say EC has an acceptance rate of 25% maybe. So majority of the papers are rejected every round, right? So let's back to the question, why don't we just accept more or even all the papers? This doesn't work. The intuition is that to do so, we have to lower the acceptance threshold tau, which means we have to decrease the de facto threshold theta. And as a result, more lower standard papers that previously are not submitted now decide to submit. And more importantly, eventually they got accepted. So we cannot just imagine that we vary the acceptance threshold tau, but the same batch of paper will be submitted and eventually accepted. That's not going to happen. Papers in this in this purple area are the new papers that haven't been observed before any time. So a different batch of paper will submit if we change the acceptance threshold tau. That's our intuition about this resummation paradox. Now we are able to talk about the conference quality and review burden trade-off. Okay? Start with conference quality. We define this as the expected sum of all the accepted papers' qualities. And this is normalized by the total number of papers. So what are the...
Just a clarifying question. So you assume that the value of the conference V remains fixed even when the acceptance rate goes to 0? Like if you accept all papers, why is the value is still above 1?
Sorry, I cannot hear you.
So the conference value is there is a conference value, right? If you accept all papers, the conference value should
oh yeah,
go
so
to 1, but you assume it's fixed?
Yeah, we are assuming that's fixed. That's indeed one of the limitations we will mention in the end. Thanks for the question. So yeah, so the conference quality will be defined as this way. So if you look at this figure, where the distribution is this Gaussian one, that quality distribution, then the conference quality will be exactly equal to this blue area, which are all the papers are about the de facto threshold. Right? So stare this a little bit longer, and then we're trying to understand what is the optimal acceptance threshold that maximizes the conference quality. That will be indeed the one leads to a de facto threshold of 0, where only all the good papers are submitted and eventually accepted. Right? So the second dimension of the problem, the review burden, is defined as the expected number of reviews solicited for each paper. And in the idealized setting, this is exactly equal to the expected number of rounds a paper is submitted, because we are only soliciting one review each round. Right? So again, look at this figure. The quality distribution is like this Gaussian, and we use color to represent the expected number of rounds a paper is resubmitted before acceptance. So you can see that the borderline papers close to theta has a darker color. That means they are experiencing a lot of rounds of resubmissions. However, good papers will be accepted probably in the first round. So the review burden will be exactly equal to the integral over this area, but weighted by the color. Now we are able to visualize the conference quality and the review burden trade-off. We call this the QB trade-off. So in this example, everything is Gaussian. The parameter quality is Gaussian. The noise distribution is a Gaussian with a standard deviation of sigma. So let's consider, so varying the acceptance threshold, how does this change the trade-off? Starting with the point of 0, 0, that's where you have a very high acceptance threshold, and nothing is submitted. All right? Then you lower the acceptance threshold. Something is submitted, so both dimension goes up. Until the point you lead to a de facto threshold 0 where the quality is maximized. And if you keep lowering the acceptance threshold, bad papers are starting to submit and accept it, so the quality goes down. Eventually, you'll reach a point of review burden of 1 where you're just accepting everything immediately without even carefully reviewing it. So one thing about this is that it seems like the smaller the sigma is, the better the QB trade-off curve is. So this is not a coincidence. That better reviews, we can imagine that the QB trade-off is better. The intuition is that what will lead to a dominating QB trade-off? Here, by dominating, what it means is that you can achieve the same conference quality with strictly better review burden. So the answer to this question is that we want the resubmission gap to be small. The intuition is like this. Let's fix the de facto threshold theta, which also fixes the conference quality. Let's allow the resubmission gap goes down. What will happen immediately is that the acceptance threshold goes down. just by the definition of resubmission gap. And this results in the higher acceptance probability for every submitted paper. Thus, every submitted paper will experience less rounds of resubmission because there are higher chance to get in, which results in a smaller review burden. Therefore, you are fixing the conference quality, but have a smaller review burden. Thus, you have a better QB trade-off curve. So let's recall that we have 3 aspects that will make the resubmission gap smaller, that are a lower value conference, and others are less patient, and reviewers are better. So this kind of have some very interesting implications. For example, if we have a conference that have a higher reputation, we should be a little bit more careful about that is attracting more substandard papers to submit. So probably we have to adjust the acceptance threshold to deal with it. And for a second one, maybe it's hard to turn in reality, but let's consider there's a suggestion that we should shorten the review process from 4 months to maybe just 2 or 1 month. We should be very careful about that because agents will be much more patient in these cases, which will harm the QB trade-off curve of the conference. All right, I don't think I have enough time to cover the other results, but we have some other results like the discussions on acceptance rate. We have some models that are not continuous but discrete, and some of these are learned from the real data. We discussed the noisy authors who cannot observe the true quality of the paper. We also have some discussions on that the policy of the conference has some memory. For example, a lot of review to follow it. I will use the last slide to point some of the model limitations and potential future works. So first, there are several additional feedback loops that we haven't considered. The first one is that conference quality will affect its value, as just the question asked, right? And second, the review burden, of course, will affect the review quality. And second, our model about author's utility is towards its best response. It cannot capture the author's utility in a holistic way. For example, we can just accept every paper, which obviously maximizes the author's utility, but this will lead to a very bad reputation of the conference. Third, we only consider one single prestigious conferences, but you can also consider like more than one, of course, and the computation, the cooperation between them can be interesting topics. Finally, the authors, of course, can improve their paper quality through time. That's not captured by our model. We think our paper is drawing some interesting intuitions on this important and not yet well understood problem. We definitely hope there will be more following up works pretty soon. Thanks. And I will listen to some questions.